These are solutions to Melham's Math 110C, exam number 5. Y cubed is this thing cubed, okay, and t is going from 0 to pi over 2, and I need to find ds. So first xy cubed is, here's x, 3 sine t, y cubed is 3 cosine t cubed, so that gives me 3 times 3 cubed, which is 3 to the 4th, 81, sine t cosine cubed t. ds is the square root of dx dt squared plus dy dt squared plus dz dt squared, okay. So I differentiate each one with respect to t. Dx dt is 3 cosine t, so I square that. Dy dt is negative 3 sine t, I square that. And then dz dt is 4, I square that. So I have 3 cosine t squared plus negative 3 sine t squared plus y squared, 4 squared underneath the square root of dt. Comes out to be 9 cosine squared t plus 9 squared t plus 16. This combination is 9, because if we factor out the 9, it's cosine squared plus sine squared. 9 plus 16 is 25. So I have square root of 25 dt or 5 dt. So I multiply by an extra 5. All right, so all of this came out to be 81 sine t cosine cubed t times 5 dt. Take out the 81 times 5, which is 405, and do a u substitution. Let u be cosine t du is negative sine t dt, so multiply inside and outside by negative 1. That gives me a negative 405. U cubed would now be u to the 4th over 4, cosine to the 4th t over 4, from 0 to pi over 2. Put the 4th with this, so negative 405 over 4. Plug in pi over 2, cosine of pi over 2 is 0, 0 to the 4th power is 0. Plug in 0, cosine of 0 is 1, 1 to the 4th power is 1. Final answer is 405 over 4. All right, number 3, you're given this is f, and I have to substitute in. R is t squared negative t cubed. That's x, that's y. So take t squared and plug it in there and there. And negative t cubed, plug it in there and there to find an expression for f involving only t, and t goes from 0 to 1. So x squared is t squared squared. Y cubed is negative t cubed cubed. And then negative y radical x, negative t cubed, and radical t squared. So if we multiply this out, that's t to the 4th times negative t to the 9th, negative t to the 13th, and then positive t cubed times t to the 4th power. Then I need r prime, the derivative of r, derivative of t squared is 2t, derivative of negative t cubed is negative 3t squared. So f dot dr, I take the dot product of negative t to the 13th, t to the 4th, multiplied, or dot product with 2t, negative 3t squared. That's negative 2t to the 14th minus 3t to the 6th. So that's what I'm going to integrate. So the integral along the curve of f dot dr is the integral from 0 to 1. So negative 2 to the 4t to the 14th minus 3t to the 6th. Negative 2t to the 15th over 15 minus 3t to the 7th over 7 from 0 to 1. Plug in 0, you get 0. Plug in 1, negative 2 15ths minus 3 sevenths, a little bit of arithmetic, negative 39 over 105. 4, determine if you have a conservative vector field. It is. So I take a partial of p with respect to y, that's 5. Take a partial of q with respect to x, it's also 5. So therefore, f is conservative. So that means fx is 6x plus 5y. That means that this is fx, little fx, and that's little fy. So I do the integration and differentiation being. So if fx is 6x plus 5y, f of xy is integrate with respect to x, 3x squared plus 5xy plus g of y. Now differentiate this with respect to y. That's nothing. That's 5x plus g prime of y. And I set that equal to 5x plus 4y. So comparing these two, here's 5x, here's 5x, g prime of y, 4y. That means g prime of y has to be 4y. Therefore, g of y is 2y squared plus k. So final answer, f of xy equals 3x squared plus 5xy plus 2y squared plus k. And it's pretty easy to double check that fx does come out to be this, and fy does come out to be that. Okay, number 5. Number 5, this language already implies that you have a conservative vector field, so you just go ahead and find the anti-gradient. Once I find the anti-gradient, okay, then I figure out my starting point and ending point, which basically means you plug in 0. Plug in 0, 0, you have 0, comma 1. Plug in 4, you have 2, comma 65, I think it is. Okay. So I find my anti-gradient of this, which means fx is x cubed y to the 4th. Integrate with respect to x, 1/4 x to the 4th y to the 4th plus g of y. Differentiate with respect to y, x to the 4th y cubed plus g prime of y. That equals x to the 4th y cubed. That forces g prime of y to be 0. We want g prime of y to be a constant. Okay. From the fundamental theorem of calculus, just like in Calc 1 and 2, the easiest constant to pick is 0. So in general, f of xy is 1/4 x to the 4th y to the 4th plus k. You're allowed to pick any anti-gradient, so the best is to use f of x equals 1/4 x to the 4th y to the 4th. Okay, you plug in 0, you're at 0, 1. Okay, way back here. Plug in 0 here and 0 here, you're at 0, comma 1. If you plug in 4, you have a much unfortunate order pair, 2, comma 65. Plug in 4, square root of 2. 4 cubed to 64 plus 1 is 65. Okay, so the integral of f dot dr is f of 265 minus f of 0, 1. F of 0, 1 is 0, because you plug in 0, that's 0. But much harder to plug in 265. So put a 2 here and a 65 here. Grind it out. 67,108,864. Okay. Number 6. Evaluate this integral. So it's best to use Green's theorem. So this is P, this is Q. So here's the picture. So 0, 0, 1, 0, 1, 2. This is y equals 2x. Y equals 0, and x goes from 0 to 1. Okay, so use Green's theorem. Double integral of partial of q with respect to x is 2xy cubed minus the partial of p with respect to y is just x. Y goes from 0 to 2x, x goes from 0 to 1. Okay, so integrate with respect to y. 2xy to the 4th over 4 minus xy. Y goes from 0 to 2x. Plug in 0, you get 0. Change 2 over 4 to 2 on the bottom. So x, everywhere you see y, put 2x, so 2x to the 4th power minus x times 2x. And so clean that up. That's 2 to the 4th, which is 16. Divided by 2 is 8. 8 times x to the 4th is x to the 5th minus 2x squared dx. Okay, so 8x to the 6 over 6 minus 2x cubed over 3 from 0 to 1. Plug in 0, you get 0. Plug in 1, you have 4/3 minus 2/3. Final answer is 2/3. Okay, number 7. Curl f or del cross f, I, j, k, partial with respect to x, y, and z. E to the x cosine y, e to the x sine y, 2z. So the I component is nothing minus nothing. The j component is the opposite of nothing minus nothing. The k component is partial with respect to x is e to the x sine y, minus the partial with respect to y is minus e to the x sine y, and so you get the 0 vector, 0, 0, 0. Okay, the divergence, del dot f, by definition, partial of p with respect to x plus the partial of q with respect to y plus the partial of r with respect to z. Partial of p with respect to x is e to the x cosine y. Here's p, q, and r, so maybe just look over here. Plus the partial of q with respect to y, e to the x sine y, plus the partial with respect to z, which is 2. I think that should be e to the x cosine y. That's not correct. E to the x cosine y. E to the x cosine y plus another e to the x cosine y. So 2 e to the x cosine y plus 2. Differentiate with respect to x, same thing, differentiate with respect to y, e to the x cosine y. Right. So I have 2. Sorry. So e to the x, 2 e to the x cosine y plus 2. Okay. Number 8, first I have to find the values of u and v. So 2, 3, 0. I solve the system of equations. 2 equals u plus v. 0 equals u minus v. Add them up. 2 equals 2. U equals 1. That means v is 1. So u is 1. V is 1. So r sub u is 161. Differentiate with respect to u. 161. R sub v, differentiate with respect to v, 1, 0, negative 1. Take the cross product, RU cross RV, IJK, 1, 6U1, 1, 0, negative 1, which is I component is negative 6U minus nothing. The J component is the opposite of negative 1 minus 1. Not a negative there. The K component is nothing minus 6U. So negative 6U minus a minus 2, which is positive 2, negative 6U. Now I plug in U as 1, V is 1. So the normal vector is negative 2, is negative 6 to negative 6. Okay. You're allowed to take any scalar multiple of that, also the normal vector. So I pick negative 1/2 times this vector to make it a little bit nicer, and I get 3, negative 1, 3. That's 3x minus y plus 3z equals k. To find the k, I plug in a given point 2, 3, 0. So put a 2 here, 6, 3 here, negative 3, 0 there, 0 equals k. So k is equal to 3. Final answer, 3x minus y plus 3z equals 3. Number 9. Okay, so you have a triangle, 1, 0, 0, 0, 1, 0, 0, 0, 1. Okay, and here's the bold f, x plus y squared, y plus z squared, z plus x squared. Use Stokes' theorem to evaluate integral along the curve of f dot dr. So when it says this, they want you to do the other side of the equation, which is double integral of curl f dot ds. Right, so here's my picture. The equation of this plane is ax plus by plus cz equals 1. In general, you say ax plus by plus cz equals the least common multiple of 1, 1, and 1, which is 1. Then you plug in 1, 0, 0, put a 1, 0, 0, that means a is 1. Likewise, plug in 0, 1, 0, that means b is 1. Plug in 0, 0, 1, and c equals 1. So x plus y plus z equals 1, or z equals 1 minus x minus y. Okay. Unit normal vector is 1, 1, 1 over radical 3. Okay. This, when I do curl f dot ds, I'm doing curl f dot n. It's a unit normal vector ds. Okay, so curl of f is ijk, partial with respect to x, y, and z. X plus y squared, y plus z squared, z plus x squared. Okay, so the I component is nothing minus 2z. The j component is the opposite of 2x minus nothing. And the k component is nothing minus 2y. Or negative 2z, negative 2x minus 2y. Okay. All right, you actually don't need this. There's a formula for the area of an equilateral triangle. It's s squared side squared radical 3 over 4. So that's one way you could get that. Okay, so I decided to do that in this case. Otherwise, you can do it like we did in class. But the area of this triangle is radical 3 over 2. Okay. S squared radical 3 over 4. So each side is radical 2. So radical 2 squared is 2, radical 3 over 4, radical 2 over 2. So double integral of curl f dot ds is curl f dot n ds, vector ds, and scalar ds. So dot product of negative 2z, negative 2x, negative 2y, dot 1, 1, 1 over radical 3. ds is the area of that equilateral triangle. We now found it to be radical 3 over 2. If you don't like that, you can do the other method that we did in class, but I wanted to show you this also. Okay, that's negative 2 times x plus y plus z. But x plus y plus z we now know to be 1 anywhere on that surface. So negative 2 times 1 over radical 3 times radical 3 over 2 comes out to be negative 1. Finding number 10. Use the divergence theorem to calculate double integral along the surface of f dot ds. You do the triple integral over the region E of divergence of f dv. And you've got the cube -1, -1 for x cross -1 for y cross -1 for z. So I just find a divergence of this. So double integral along all surfaces of f dot ds is a triple integral over the region E of the divergence of mode f or vector f dv. So divergence of f is a partial of p with respect to x plus partial of q with respect to y is a partial of r with respect to z. Okay, derivative with respect to x, it doesn't have any x, that's 0. Derivative with respect to y is 9x squared z squared. Derivative with respect to z, there is no z, so it's 0. So 0 plus 9x squared z squared plus 0. So I'm integrating 9x squared z squared. So triple integral over the region E of divergence of f dv. So all of them, x, y, and z, are going -1 to 1. 9x squared z squared. I put dy first, then dx dz, because there is no y, so just take it out as the length of the interval. The length of the interval is 2, so 9 comes out 2, that's for y. Then I integrate with respect to x next, so that's x cubed over 3z squared. X goes from -1 to 1. Okay, so take the 3 out with a 9 times 2, 18 over 3 is 6. I put 18 times 1/3. Okay, and then plug in 1 minus a -1. And then I'm going to integrate z squared from -1 to 1. Okay, so it's 18 times 1/3, which is 6 times 2 is 12. 12 z cubed over 3 from -1 to 1. 12 divided by 3 is 4. So 4 times 1 minus a -1, 4 times 2. Final answer is 8. All right, so these are solutions to Milham's Calc 3 exam number 5.